guys, in this lecture we'll be talking about the valence bond theory. First of all, valence bond theory was discovered or introduced by London and Hitler in 1927, and this bonding is about the covalent bonding by overlapping of the bonds or of the orbitals. Now the main postulates of these bonding are: covalent bond is formed only when half-filled orbitals of atoms overlap with each other. It's not the whole dissolution, it's only the overlapping of one axis or one number. A single covalent bond is formed by overlap of half-filled atomic orbitals, whereas a multiple is formed by overlap of more than two half-filled orbitals. Each overlapping atomic orbital should just contain an uncertain electron with an opposite spin. If a body is containing in pair form, there would be coordinate covalent bond, not the covalent bond but the coordinate covalent bond. It is like compulsory that electrons should be unpaired to make a covalent bond. The strength of a covalent bond depends upon the extent of overlap of orbitals between the two atoms. The greater the extent of overlap between orbitals, the more the energy and stronger. Now let's discuss about the overlapping. First of all, there are few conditions for overlapping. Non-metals and unpaired. As I told you, if the electrons are in paired form, it will be coordinate covalent bond, not the covalent bond. So it is the condition that it should be unpaired, plus it should be non-metal, because non-metal atoms have a small size. Orientation should be same, axes should be same, and energy should be same. Of course, if we know that we are talking about the S shell, so S shell will be overlapped with S shell, just in order to make it energy same. If in pair, it will be coordinate covalent bond and also lone pair. As I told you, if it is unpaired, it will be covalent bond. Now here the coordinate covalent bond is shown by the arrow, while unpaired is shown by a line. As in nitrogen, we know that in nitrogen there are 5 electrons valency. Now we'll pair these two like this, as there is a rule for that if we are making it like electronic configuration, so we will first like N. We have 5 electrons in valence orbit, so we will just place it here 1, 2, 3 and 4. And after that, if it is greater than 4, then we will start filling it in pair. So there are 5 electrons, so we will fill 1 electron extra. And like this, we will having 1 coordinate covalent bond and 3 covalent bonds. Now there is a key point for you all guys, that if the thing is metal, the atom is metal, so it will be ionic bond. If it is non-metal and unpaired, covalent pair, coordinate covalent bond. Now let's talk about the overlapping. First of all, we should start from the overlapping with less energy, SS overlapping. Just suppose these two are the SS orbital, or we can say that just suppose this is the orbital of H atom. Now these two H will combine with each other or overlap over one another to make the SS overlapping. Now it will always be in x-axis. It will contain 1 s of hydrogen, and there would be sigma bond, because we know that if there is an x-axis, it would be sigma bond. Now let's talk about S and P overlapping. Now here orientation is same, so we will gonna just add that. Now it will overlap. We knew that there would be half of the S and half of the P. Not double dumbbell, half of the dumbbell. So both are in the y-axis, and we know that H configuration is like this and F configuration is like this. Now here we have three valencies. So there would be the valency that should be filled by the H. According to Hund's law, 1s of H and 2pz of F will make the covalent bond as they are unpaired. Otherwise, remaining one would be paired. So there would be attachment of S and P by the 2px and 1s1. PP overlapping. Now this is a linear overlapping in x-axis, or we can say that as single axis. So when it will overlap with each other, there would be a condition that we know that these both are electrons of fluorine. So here would be configuration like that, as I told you in the previous one, that sp overlapping is also in, as we know that if we are talking about as, there should be the atom of helium or hydrogen. We can take helium or hydrogen. Here hydrogen has valency, so we had taken hydrogen. Now in this configuration, according to Hund's law, there would be pair of 2px with 2px. Now that's the condition that it should be in the same orientation. So in same orientation, pp overlapping is done. Now pp overlapping again. Now in this condition, when it will overlap with each other, there would be two types of bond. Now we know that when their bond is in this process, or we can say that if we have three valencies here, so we're gonna just write it like there. Now these x-axis, the bond in x-axis would be sigma, and it will be, the remaining bonds would be like cloudwise, and these cloudwise bonds are called pi bond. And we should be known that with the strength of the sigma bond, the pi bonds held like a cloud. Now let's talk about the energy. We know that the SS overlapping has less energy than SP, and SP has less energy than PP. How? Let's focus on the configuration. We know that when these two bonds of same region of hydrogen overlap with each other, so there is less energy. Now here, when H with the double dumbbell electron would have configuration, so there would be more energy because there would be more nuclear force or more bigger atom. Now in the third condition, there is more bigger atom, so there would be the greatest energy. And that's all about today's lecture. Thank you.